Hello. I'm surprised to see some people still at 6 o'clock in the evening, so that's pretty impressive. We're going to talk about automotive-grade Linux. So I'm Dominic, I work for Intel. I see people doing pictures. I already posted my slides, so you can find them on the internet. So if we keep about working. So what is automotive-grade Linux? It's a distribution based on Yocto, using really upstream component. What we have different a little bit is that we have tried to make something which was a little bit more focused on the automotive. And the reason why I'm here today is not only to explain you what is automotive-grade Linux, but to encourage you actually to look at that project if you want to do industrial project outside of the automotive, because when we talk with people, we realize that the need of a lot of people is very similar, and independently of the fact that you're looking at automotive issues, or you're looking at industrial issues, or even building or smart cities. So AGL is an open source project which is sponsored by quite a lot of big companies. Originally mostly driven by manufacturers of car manufacturers coming from Japan, but we have since been joined by Ford in the United States and very recently by Daimler in Germany. But we also have some software houses, and we have people doing equipment for cars. And at a lower level, we have even more people. People like Advanced Telematics that you have just seen before this presentation are members of the AGL and are working on the project. So it's a lot of people at the end of the day, and all of them have a direct relationship with automotive, but everything is really in the open. So who is working on AGL? I don't know if the numbers mean anything, because I still don't know how the Linux Foundation does it, but it gives a little bit of a ranking. And definitely the number one guy on AGL is José, who is there. Okay? So if you want to talk with him. And I have to say that is the best one for the second year in a row. I know that some people are trying to get him out for the third one, but they still have to prove they're capable. What we can see here is that actually we have quite a number of people who are committing, understanding that in AGL we are not really developing a kernel, we are probably making a distribution with mostly existing components. So we have a few small things that we are developing, which are being developed specifically for AGL, and we've talked about it. But most of them, like OS3, are actually projects that are coming from the outside world, from the open source, that we are integrating. So, what is AGL itself? It's an embedded Yocto-based build. So a lot of people believe that Yocto is a distribution. I will not go into semantic of do you say that Yocto project or open embedded. No, let's forget this conflicting marketing discussion for after the beers. But at the end of the day, Yocto provides development tools which allow you to build an embedded distributions. And we're using that. Is it the best tool in the world? If you ask me personally, before I was using OBS and I still prefer it, but it's a tool that people know. And at the end of the day, it's a tool that you're capable to deploy and you're capable to scale up with, because you can hire people who understand it and you can subcontract to companies who are capable to use it. We obviously, because we work in the industry, we had to make a system initially that would immediately start to have capability to have a very strong integrations with sensors. In the cars, you have a lot of sensors, and obviously we had to get that readable by the software. We could not have a desktop UI. Nobody wants to drive a car with a mouse. And even a touch screen is sometimes on the very strong edge of what you can do. So the user interface is very specific. Furthermore, a very important point which is driving us in AGL is that we know that the people who will use AGL, all of them want to do their own user interface. So we cannot do what we do in desktop, where you either use GNOME or KDE, and then you have a few exceptions, people using one of the 200 different desktop available on Linux. But the majority are there, using either GNOME or KDE. Now, in automotive, every car manufacturer wants to have his own UI, and actually in every car series, they want to have their own UI as well. It's a huge differentiation. It's actually likely one of the most important ones. So we had to think from the very beginning of making an OS with a distribution that would not be assuming any type of UI. When it comes to the technology of the UI, we also had very strong differentiations. You know, some people are saying, we're going to use Qt. And some say, yeah, we don't want Qt because we don't want to buy the license, and the GPL3 in a car is not really something we can afford to put in. And you know, some others said, we're going to work with HTML5, but on the other side, on some CPU, having a very performance browser is still a serious challenge. So not only on the design of the UI we cannot agree, but actually on the technology of the UI, we know that we cannot enforce anything. One specific thing which is very different from a desktop in a car, you have specific buttons. Typically, they are sitting somewhere between the dashboard and your steering wheels. And you have a lot of them, so you have to manage them. And in modern car, you have multiple screens. The one that we all know is the one where we have the GPS, somewhere with a radio in the middle, normally, of the console. But we also have now what the industry calls a cluster that, you know, people like me call the speedometer. You know the thing you have in front of you that tell you, you know, how quickly you're going and if your car is overheating. So that is another area. It's also a screen, you know, from a computing point of view. And you start to have screens in the back of the car. But you also have people wanting to interconnect their tablet, which becomes then a screen into the system when you're driving. So the type of screen, the shape of the screen, the definition of the screens are different. Now, if you buy the car Prestige or the car Popular of the same series, likely the screen is not the same size and not the same definition. So you also have to take that into account. So we had that very big thing that we had to deal with. Well, the second big thing in Linux was that we had to deal with a managed device. And this is a big importance to understand. You know, in this world of the FOSDEM especially, we have a very strong open community. And people are saying, okay, I'm going to do my own system. I want to hack the system. In reality, when you do certain type of device which are managed, you are legally responsible by law when you give the device. Before working on automotive, I was working on television. I already had the same problem. So in a managed device, you cannot, in reality, let the user change the device, except if he really, in a formal way, has a traceable way to prove that he actually decided to break it, and so take the ownership. And that is a big issue we have, because on a managed device, definitely any fault is going to be blamed to the poor guy who shipped and sells the product. Now, in the car industry, it's very strange, because the guy who develops the product is not the guy who shipped it. So you buy a car from, you know, PSA or from Daimler or from BMW, the radio system in it is not only coming from them. They bought it somewhere else. And if you look at the very detail of the contract, the responsibility is supposed to be with the one who provided the system, which could be an Harman or, you know, a Continental or a Bosch. But in reality, from a user point of view, this is not the way it works. You buy a car from Mercedes, you go to the Mercedes dealer, and you don't want to know if the radio system is coming from Bosch, from Continental, or from Harman. If it doesn't work, you know, it's the guy who sold the car that will have to fix it. So on a managed device, very quickly the responsibility of any problem comes back to the guy who sold it. And that's an important point. The second issue is that all the application which runs traditionally on a gated device are actually checked by the guy who sell it. And you know, the application which is, for example, capable to receive, I drive a Volvo, and I can have the internet streaming system which is in the car. That is actually an application which has been gated by Volvo. They have tested it. They have checked that it works. We are not in the world of Android or iPhone or a PC where you can get an application, from a store which has been kind of, checked that it didn't do very bad thing. Or even on a PC, on our Linux distribution, you get it from the official distribution or from a friendly repo within the distribution, a user repo, or even completely outside. That's not really possible. And they have long life. Now, in the car industry, typically the time which is said varies depending who you talk to, between 10 and 20 years. So let's put something in the middle, around 15. When I was working in the TV industry, it was typically 10, and before I was in the telecom industry where it was 23 years and 3 months. Don't ask me how I calculate that. It must be a very round numbers of seconds. But that is very, very long time, especially within the computing world where we are used to make a new system, every other day, okay, to be honest. And I heard a lot of people saying the future is for rolling distributions. You say in managed device, it will take quite a bit of time before it does arrive because you have a lot of constraint to not doing it. And finally, a very, very big differentiation on a managed device is that there is no admin. So if the system crashes, if the system is to be reinstalled, you cannot rely on an admin. You cannot rely on a skilled person. That doesn't exist. So everything has to be embedded into the device. Now, this is what we did in the automotive industry. That's what has been driving us, and this is what is still driving us. Now, the reason why I wanted to present that is because we believe that between the automobile and the industry in general, and even in certain type of complex building or smart cities, there is a very, very strong synergy. And the fact that the features we are providing are traditionally something which are not surprisingly very different. Yes, we have speed, position, and sensors. Now, the fact that you have a speed, position of the sensors for milling machines or for knowing, if the lights are working well in a city or if the door are open in a car, it actually doesn't make any difference. From a software point of view, it's exactly the same type of framework. The UI is dedicated and is very unique. It's exactly the same. The UI is from a lift is going to be very different from the UI you are going to have on a machine which is controlling and weighing trucks when they get out of a quarry. So you will have different UI every time. You will have dedicated entry buttons. You're going to get multimedia features. Now, on a milling machine, you don't have multimedia feature. Okay. While the guy is working on his machine, nobody is going to let him access, his best streaming stuff so he can see series. But in a lift, you're going to have a multimedia because they want to do advertisement. So it's not uncommon to see them. You're going to have an emergency phone service quite regularly. A lot of devices will have an emergency call. It might not be over a phone. Typically in the factories, the machines will have an emergency system that will have to connect on a phone, especially if the guy working alone. So this type of services are not unheard of. And finally, it has to be remote diagnostic as well. So it's not very different. We have the same things. From an implementation point of view, we are not different either. This industry is using Linux. I'm sorry to tell to the people who believe that Linux is the best and everybody should use it because it's the best. They didn't use Linux because it's the best and because it's the nicest. They used it because they had nothing else and could do the job. Okay, and quite often it was a connectivity into the network which was one of the drivers to have to select a Linux. And we come back to this issue of connectivity. What type of bus do you have? In the industry, you have plenty of different type of buses. Are they all managed by Linux? Yes. So we already have that. Okay. If you are remote, what are you going to have? Likely a 3G or a 4G. Do we have that capability? Oh, yes, it happens that we integrate actually it for the cars. So this is type of things we have. And it has to be 100% remote support. When you have a factory calling you, you sold a big machines, and you're living somewhere like me, in Brittany, in the very west of France, and you have a guy calling you from Denmark and say, my production line is stopped. you're not going to tell him, okay, let me look at the train table and I'm going to go to see you, and next week you will have someone who maybe will be able to fix your problem. It's not going to be very good. In general, you're going to say, okay, that's your machine, I have that contract with you, and I'm going to log on your machine, I'm going to try to start again your factory immediately. So we are on a very, very similar type of things. So if the requirements are very similar, and we have, in one way, in AGL, the remit to still go in that direction, let's have a look at, what we've been focusing on and what potentially we could reuse. We are focusing on the core OS. That's a very important thing to understand. In AGL, we are not really trying to do the application. We know that the car manufacturers are far better than us to find people who can make a very nice looking radio or a very nice navigation application. Now, if you go, and I invite you to have a look at our demos in the building AW, we will restart the demo tomorrow. We have a table there where we are showing AGL working on different hardwares. We have a demo, obviously, to show. We have a get UI and to let people understand what we have done. But this is not what we're focusing on. We are really focusing on the core of the OS, which allow you to build what you need on. We are working on a reasonably recent type of code. So we are based on Yocto 2.2, which was released just before Christmas. Okay, for some of you, this is ancient, almost prehistoric. Okay, it was last year. For us in the industry, that's very new, okay, and still very green. The kernel we're using are either 4.4, 4.8. I am going, at least on the Intel side, where I work pushing to 4.9 because I need a few features. So we are working on kernel which are definitely reasonably recent, and the reason is because, we'll see later, we are using some security features from this kernel. There is option to make backport, but then, hey, once again, you are by your own, and my advice is try to use what we do rather than try to reinvent the wheel. The security model has been one of our big drivers. It's actually been mostly derived from Tizen. It happens that, for historical reason, the team which is working on the security side of AGL has worked for numbers of them on MeGo first on TV side, which had some security serious problem, and then on Tizen Common and Tizen AVI, and now we're working on AGL. Why do we stick to that model? There is a very simple reason to that. The first one is that it's a pretty light model from an embedded point of view, and secondly, Samsung is just shipping millions of products, especially televisions, with the same or very similar security model, and so we have a real test of them. What is our goal? Our number goal in security, and this is really cybersecurity, is that people using AGL will not be the first to have their car locked. One day someone will arrive to start a car in the morning, wanting to go to work, and it will have a nice drawing showing him a nice hacker saying, hey, you have to pay me 10 bitcoins if you want to go to work today. We don't want that to be an AGL car, okay? We'd rather to be it with another distribution. Now, it will happen. And we believe we are trying to do our best to avoid it to be us. So now, if you think about a factory, you have exactly the same problem. If you take a factory which is producing chocolate and you actually lock the factory chain, during 3 days, 2 weeks before Christmas, you bankrupt them. So it's a very nice way to deal with competition. Once again, it will not be acceptable. And that with IoT, especially when IoT come into the industry, is a problem that needs to be actually seriously looked at. Now, on a working point of view, we are working on standard BSP provided by Yocto with the small caveat that the kernel has to be recent. That means that you may not have to get everything 100% open source. It's nicer, it's easier, but it's not mandatory. And it's not uncommon that some SOC have, especially on the multimedia or on the communication channels, some drivers which are not open source. If they come with a BSP from Yocto, we are actually capable to actually work with them. And because we want people to be able to work and write application without dealing with Yocto, we provide an SDK ready for that. So this is what we have today, and this is January 17. So that's what we did present at CES 3 weeks ago, and that's what we are actually demonstrating again today and tomorrow. In order to help people to write application, we arrived to the conclusion that we needed to extract the writing of applications from the embedded business. The reason is very simple. If you look at the world business of developers, you have roughly about 500,000 embedded developers available in the world. All of these people already have a job. Numbers of them are old, and there are more people of that class going on retirement than new people coming from university. So the system makes that the solution is today bad, and tomorrow it will be worse. So we wanted to enable people to use other type of developer to write the middleware and to write the application. Now, we look at what is available. We have about, 8 million people working on mobile application and about 7 million people working on web application. We thought, this is a very nice thing we would like to tap in. And so we have tried to isolate our way to write application and middleware in such a way that we can actually use this type of people who are available, and then you just need a few people doing really the very heart of the platform using Yocto. So from an architecture point of view, it's pretty traditional. It's not very easy to read. You will have to download my slides. But we arrived to a very standard system where we have at the bottom, we have the operating system. So this is a Linux layer where you have your traditional drivers plus your services which are embedded in your kernel. On top of that, you are going to provide services, and those services are typically what we call the middleware. Most of them, not all of them, but most of them, we actually run them as application, which means they're going to run in an isolated security context. We'll see that in a minute. And if obviously you go further, you're going to have the application framework, which is really isolating the way we progress communication between application and the core system. And on top, you have different type of application really which are running and which provide your connectivity and whatever you wanted to do with the box. The security system is shown as vertical because it is in everywhere point. Now, I insist on that problem of security, and here security is in the sense of cyber security. We decided in AGL to put security from day one in the design. I see some people here who came to see us from other project a few years ago, and we had a long discussion on that. Can we add the security after the fact, or do we have to make it from the beginning? Anyone who is cooking knows that if you put the salt at the last minute on the plate, it's not very good. You have to put it when you cook. The only exception are the chips in Belgium. But security is the same. You cannot spread security at the end and hope that it will work. Now, some people still dream that this is possible. If one day they succeed and they demonstrate it, we will be very happy to change our mind. But so far, all the people who have tried to do it like that had it wrong and have failed. So we decided that we were going to go with the mass and assume that it was something pretty well accepted in the industry, that was a wrong way of doing it. In order to get the security working, you had to actually design it in. And the driver we had was very simple. Everything which is not explicitly allowed is strictly forbidden. Okay? And we actually put that in the entire system. I have had, because I've been pushing that system for more than 6 years, the only difference is that when I started, the room was completely empty. People say, yeah, but how are we going to know what we need? And my answer is very simple. If you don't know what you're doing, you should not do it, okay? And that's a very important point. So if people are coming to you and say, we cannot put security on a whitelisting, just think it twice very seriously. You should know what you're going to do. And once you have decided that you were going in that model, you have to provide a model to implement it. And the way we actually implement it is a set of functionality. The first one is a very obvious one. Okay? You don't want to run everything as root. We have all heard about a huge attack on OVH, because that was the first one to actually pass 1 terabyte of data. And why it was created? Because some video camera are running the application as root. A lot of embedded systems are still done like that. So that's very basic. So you have to look at that. So using the DAC is very important. DAC for discretionary access systems. That's what we know as the traditional access right from Linux. But we also use a mandatory access system. And the difference is that on a mandatory access system, the application cannot change a write. So if the OS says that application cannot write that file, it cannot change it. While otherwise, as a user A, you can always give write to user B to use your file. So if your application A is actually hacked, it has a possibility to open the system. With Mac, it's not possible. That is actually enforced as a policy level. So you all know Mac because SC Linux on CentOS or Fedora or Red Hat are actually using, it's actually a Mac. And on people using Ubuntu, OpenSUSE, it's AppArmor. And SMAC that we use is actually in the same family. We're using exactly the same module. So we are probably using the LSM module from kernel. And it's just a way to activate it, which is lighter, which takes less CPU. You cannot do things potentially as complex, which is good and bad. The bad side is that if you want to do things extremely complex, you may not be capable of doing. The good thing is that when you read what you have done, you are capable to understand it. Which is not always the case otherwise. The second thing we did on the access is not really directly there, but we separated the access to the system with a Mac with what is allowed to be done by an application. And for that, we have a system inherited from Tizen, which is a system of checking the privileges that what an application is allowed to do. And we enforce it in different points of the system. If you think about an equivalence of trying to secure buildings, that would mean that you probably do a first step, you do a fence around your building, and that's your first door. But actually what we also have done is that we create side isolation. So when you're in floor 1, if you want to go to floor 2, hey, you have to get a special pass. Otherwise, you cannot do it. The other point that we are looking at is how can you drop privileges? And we have in different ways to do it. The first one is a Mac. Actually, the Mac allows us to drop privileges and to stop application to make some specific call or to touch at specific resources. But we also have other methods into the Linux kernel to drop privileges. We have the bcomp filter, which are there, which are probably used by a browser mostly today. But we also have the namespaces, which is another way to drop capability to go sideways within the system. And finally, we have the C groups. And the C group is another way to stop a system to do too much. So we are using all of that. The good thing is that it makes a system by layers, and the layers are pretty easy to understand. Someone told me, yes, it looks like an onion. An onion have two particularities. One, they are stinking, and the second one, they make you cry when you use them. Security could make you cry when you use it, but it will make you less cry that if your customer gets his system lock. So it's a question of deciding what is more important. Once you have segregated your app from your OS, you really have to think now, it's very great, I have an OS, it's completely locked, how am I going to execute anything? And that's where the application manager comes in. And you heard our friend talking about OS 3 before, explaining that the application framework was creating some side effect to his system. Yes, it does. And obviously, the installation, the running of an application, the delete of an application is done through the application framework and is not part of the image. Now, people using desktop are very used to that system because that's the way you use a desktop. In embedded, it's significantly less frequent. Now, our phones are working in that way as well. So it's not a complete new system. But for embedded people, it's a little bit new. The security manager is a complement to the Mac, and this is enforcing what an application is allowed to do. Remember the initial statement, everything which is not explicitly allowed is strictly forbidden. So that's the principle. If an application, when you install it, has a right which is described in the metadata, to say that this application is capable to talk on the network, then it will be allowed to talk on the network. Otherwise, it will not be allowed to talk on the network. So that is provided as a tool, and we're using a project, an open source project coming from Samsung in Poland called Sanara. And finally, we have implemented a system of service binders. The service binder is a specific development to AGL, which we believe is of a huge interest for people trying to do industrial Linux. What it is, fundamentally it's a daemon which presents a standard API to provide a service. So we are separating the business logic from the UI, but you can also slice your business logic in multiple compute entities which are running in independent security context. The communication between them is done through WebSockets with an authentication system. That is interesting for two reasons. The first one is that it allows you to use web developer because they know how to do that. Hey, first problem, where do I get the right people to write the code? The second interest of it is that when you develop your code, you can run it outside. So you don't have to write your code on your target. You can write your code on an external box, use the network, and just do the integration at the last minute. Or you could decide to run your UI on a tablet. Oh, that can be very interesting. Where your maintenance guy is coming, he just can connect to the box and he can use his UI, or for remote debug. And yet you don't have to develop anything extra to do it. You know, that's nice. So it has a lot of nice beauty coming with it, which are interesting. So how are you going to do that? Very simple. You're going to create agents, and those agents are going to do very specific things. So in the example taken from cars, we're going to have an agent talking, for example, to a CAN bus. But if it is in industry, it would be talking to a Modbus. You know, it's not much difference. And it's going to present this information into a transport access and transport with access control enforcement, which is our WebSocket system that we call the binders. And we're going to have applications which are going to talk to that system. So this is how you work. So when you want to do an application on AGL, you just have to think that you're going to have to separate your business logic in smaller parts, and you're going to work them independently, either by the use of them or by the security level, or by the fact you want them run them locally or remotely. And then on top of it, you will plug the UI. Now, do you have to separate every single thing in slice? The answer is no. We are still on a standard Linux, so if you want to actually pack a number of things together in one, if you want, entity, you can. It's not always the smartest things to do. It's not, and sometimes it makes sense. It's your call. We are not enforcing a way you have to slice it like that. The only thing we're enforcing is that a binder is going to run is one security model, which means that it's not going to be able to hack things and to pass things to the other binder like that. We had a very funny experience, very interesting in a workshop just before Christmas in Japan, where our friends from Toyota, we were doing integration for a demo CS and decided to copy a file from one directory to another one because it would be very nice for the next application. And when they try to run it, you know what, the system just shoots them. And we say, hey, that's normal, you know, it's designed for that. So you have definitely not that capability. But beside of that, you really do what you want. So, do I have to use always a WebSocket? The answer is no. For legacy reason, we also have provided capability to work with dbus within the same system. Now, should you do it? The answer is when you have to do it, yes. But from a performance point of view, it's going to hit you badly. So you likely don't want to do it. Secondly, if you are running on dbus and you want to extract your stuff on another computer, even for development, you know, it's very nice. You have your small box and you want to debug on a PC where you are writing your code. that is significantly more difficult. But if you have a legacy application working like that, there is capability to actually integrate it, which is of interest. Now, where do we go? And that's a very important difference between what we have, which is what I have been presented today. So if you download what is AGL today, you will have what I have told until now. But the where we go is the next step. And this is our roadmap, if we can talk about the roadmap in open source. Okay, this is our wish list, put it like that. Okay, assuming that we will find enough people to do it. We are working on how to implement probably a low-level first use of the hardware for security. So we want to do that. So on ARM, it will be a trusted boot, a trusted zone, and on Intel, it will be a trusted execution zone. The technology are slightly different, but when you look at the architecture level, they are very, very equivalent. And our goal is to enforce a number of areas like, for example, the installation of applications, how we can sign keys and so on, so that is executed there. The other area of work is on the hypervisor, and especially on low-level hypervisor. We are looking at an open source project called Jailhouse. It doesn't mean we will use that one, but definitely so far that's the one we're looking at because we don't know any other equivalent in open source. And the idea is how we could actually let some very critical function be executed in an isolation in such a way that if Linux crashes, this function stays. So if you do a lift, it could be of interest to know that, if your multimedia player is for any reason crashing your Linux box, that's not going to make that the lift is going to fall down. Okay, it may stop it at the level 0, which is a very interesting thing to know. Or when the fire brigade is going and put the key to say, hey, this is fire, you know that the lift is going to come to level 0 and stop to work, because when there is fire in a building, the lift should not work. So this is what we are working on. We are working on that part. The other part is that we would also love, and that's likely a longer term, to have potentially multiple Linux-type guests. And the idea, for example, would be to have a Linux AGL running the traditional and potentially for playing to have an Android in the game. But that is a bit more complex. And it might not be easy to have both at the same time. So our initial requirement is really on the low-level hypervisor level to implement some critical function, which likely is actually also more in line with what the industry wants if you want to do an industrial Linux. Okay, running one user interface and Android at the same time may not be the most important things to do in a lift. Compared to have the capability to put the fire key downstairs and know the lift is going to go down to level 0. So this is where we are, where we go. Now, if you want to build it, when you're going to go on our website, you're going to find that we have a collection of log2layer. We have 2 official boards that we are supporting, one from Renesas, one from Intel, and we have community board, which are supported from the outside community. The one which is really very nicely supported as a community board is definitely the Raspberry Pi 3. It's a very popular one, and there is a very active team on it. But we also have a Qualcomm board, which is supported, and a Texas board. So if you go to the demo, tomorrow you will see actually the Raspberry, the Intel, and the Renesas being demonstrated. And in that, we have multiple hacker boards. So it means that you don't have to be in the automotive world to actually use AGL. On the Intel side, AGL works on a laptop. So it will work on a laptop or a NUC, but it also works on a Minoboard, and it works on a Joule, which are hacker boards you can buy anywhere on the internet. On the Renesas side, it's actually working on the R3, which is kind of available on the internet. It's just coming, but it's more likely going to be next month than 6 months. And you have the Raspberry Pi 3. So you have boards you can buy and can start. So if you're doing your own design, it's something which is not stopping you. You can do all your prototyping and all your proof of concept without even have to wait for any hardware. And you have, without even bothering, a hardening from day one, which is going to be very nice when you're going to tell to your boss or to your customer, we're using a distribution where you have people who are looking at cybersecurity. It doesn't mean they have planned everything. It doesn't mean they are the best, but at least they have taken care of it. And the model they are using is actually surviving in the world on all the Tizen TV, which is all the new connected TV from Samsung, which has actually the biggest market share in the world. So we're talking about several hundreds of millions of devices in numbers of countries which are resisting today to that problem. So it's a good base compared to traditional embedded, where the only thing you have is a trusted boot, and as soon as you are connected on the internet, you have nothing. So you can try to redo the same thing. Before you have the same level of knowledge, you may spend a little bit of time. Secondly, when you tell to your customers that you use a security model which is deployed on hundreds of millions of devices, it's more credible than when you say, you know, I'm very smart and I know what I'm going to do and it will be good. So that's coming from the beginning. We provide the most critical services to start with an industrial project. We have the sensor capability, we have local and remote UI design capability, and we have, you know, all the tools to install the application, to build an image. So that's actually coming for free. And we designed it to add extra things. You know, as I've said, in AGL, we're not trying to do a system that is going to be the same in every car. We try to provide the base core OS with a few very critical elements which are very difficult to develop by car manufacturers and their provider of equipment in order to help them to speed their development. So it's the same for you. UI, we're not going to impose it. That the good thing, the bad thing is that we are not going to provide it. You will have to do your own. But on the other side, the way to develop it is pretty simple. And likely most of industrial design are going to use a web-based type of UI because that's easier things to implement. Especially when you have to do the screen, which is remote quite often from the control unit, is a very easy way of doing it. Application and middleware are not going to be required to be developed on Yocto, which will ease the fact that you don't have to get so many embedded experts to do the job. And this is going to be a very good news if you have to do a project, because hiring them is a bit of a nightmare. So that also comes as part of it. When you will write your application, you will just have to package them. The package format we use is the same as the W3C. It doesn't mean that it has to be written in HTML5. It just means that we use the same format. Now, it can be HTML5. An application could be written in HTML5, but it doesn't have to be. And actually, what we are showing today on our demo for CS was mostly written in QML. But we still use the same format. And with that, you will have directly the framework to start either a traditional application, which is really running as a cluster, as an embedded closed system. But you could have some entertainment, or you could actually connect directly with the cloud. You have all the tools to do that in an embedded device with enforcement of a quite serious numbers of cybersecurity features. Now, as I've said, the security model with this layer is a pain and will make you cry. So you really have to think how important that is for your own business. We know that systems are attacked. And the most common model today, which is also the biggest risk model, I would say, for the industry and for the car industry in particular, is a ransom model. The ransomware is likely the most common one. Trying to get money or trying to put down the competitors is the most likely one. And the idea is, how can you immobilize a very expensive asset? And if you can do that, you can immediately get a very strong ransom. It can be done for competitive advantage as well. You may not want to block the system, especially in the industry. For example, having the capability to know the reject into a factory would allow you to know what the manufacturing cost of your competitor. Once you know the manufacturing cost of your competitor, you know how much you have to go down to actually put him out of business. You don't want this information to go in the public. Actually, at Intel, the yield, which is the numbers of defect of a chip, is one of the most hardly kept secret, because it worth a fortune from a business point of view. So you don't want that. And then you have the indirect side. Having your device been used to do a DOS is not something which is going to use your business. Think about these routers, without giving any brand, where the vendor recently had to say, if you want to fix a problem, the only thing you can do is to bin your stuff and buy a new one, okay? And every expert will tell you preferably from someone else. This is not good for your business. So you don't want that either. You don't want to be the easy entry point. If you develop a system which is going to go in a smart city, and that system is used to actually make attack, you're not going to sell to the second city. You will be just put out. So it's a very important thing to realize that the business is extremely valuable. The business of hacking, the business of cracking the system is extremely profitable, and you don't want to create it. So in that, you will have to take into account two big things. The first one is security fundamental. So in AGL, we're doing it all the time. So if you use AGL for your project, you will have it de facto, as I've said, with the pain of having to use it as well. Okay, but it's coming in. You cannot even deactivate it. Okay, some people try to deactivate it, but you have a lot of things that will not even work. So that is coming with it. And the good thing is that because we planned it from the beginning, you will be able to apply patches. Numbers of you, I'm sure, knows from embedded projects where they developed the stuff and they were stuck on a kernel, and and they see the list of CVEs that say, hey, that kernel has 300 known, backdoors. What are you going to do about it? We would love to correct it, but we cannot. Now, the good thing is because we integrated that from the beginning in AGL, we cannot make a system where we cannot change that. And because we don't do it for us, if you reuse our code, even for something else, that will come for free. The second important point is that you cannot rely on human. If you rely on human, you're doomed on security. Humans are unreliable. So you have to rely on processes. And this is an important point. Now, why are they unreliable? The first one, you don't find them. I told you there is about 500,000 embedded developers. Now, if you look at the embedded developer with a knowledge in security, I don't have the number, but I can tell you it's going to be very low. 3 they are guessing at. And out of that, 1 is there, because the reason why Jose is actually the highest committer in AGL is because he is in charge of actually most of the security mechanism. So, yes, there are very, very little of them. And not only there are not many of them, but likely you're not going to be able to hire them because they have a job and they are very well paid. So it is difficult. But on the other side, humans are not reliable because they have plenty of excuse for not doing it. So if you give them half of an opportunity to not do it, they will actually let the security out. And then you will come to the final project and say, oh, by the fact, what about the security? Oh, yes, we would have loved to do it, but we didn't have time. Now, if you work with our system, the good thing is that you will have it from day one, and you will have the pain from day one, and you will learn to live with it. Now, if you don't want to live with it, use something else. But if you are interested, it's coming with it. And we don't do any black magic. The system and the basic principle of how to harden a system have been known for quite a number of years. It's just that it was only done in very expensive technology. I worked on a big project at British Telecom, and I tell that to a lot of people, which had the capability and still has the capability to cut every single telephone line in the country, 30 million houses. Did we have some security? Yes. Was the problem as bad as today? No. But it was expensive. Now, when you do a camera, you cannot afford to spend the same amount of money as when you do a full operating system for a complete telco. But with IoT, you have to. If you do a smart city implementation, you have to think about it. And that's why we are actually proposing our AGL for this type of usage. Now, there is a reason why we're pushing it, okay? Because we know that if you start to use our system, you will find bugs, you will add features, you will potentially write documentation that will be really cute. But we are going to get it back as well. So we are interested. Let's be honest. It's not a free. As say our friends from Britain, there is no such free things as a free lunch. But we believe that we can provide you a real value, and that in return we will have an equivalent. Which brings me to my conclusions. Okay. We believe we can help you. AGL is definitely industry friendly. And the point is that you can reinvent your own system yourself, but some people who have been pretty well respected, at least in this community, just believe that this is stupid, as we do believe it is stupid. Now, with this, I'm open for questions. This is a view of what we can see when we fly about the place where we live. So which is a nice place in Brittany. So if some of you are coming, we're welcome to visit us. And I also have put in the presentation, which is already on the website, the link to AGL documentations, and actually a video I did posted last week on how to put AGL on an Intel Joule, which is a demo which is running, or one of the demo running on the table. With that, is there any question? Yes?
You know that there's a number of features, security features built in. Security is process driven. So we have a hazard analysis or process in place so that I actually can decide which of these features I need for a specific situation, or is just turning on everything and trying to nail every doorway as possible.
Yeah, the question is pretty complex, which is about unique features and how to track them. In AGL, we fundamentally use what is available in the kernel. We are not writing a new security feature. The only thing we do is that we try to make them available by default in a way which makes sense. But we don't rewrite things. And so far, we've been really focusing on the cybersecurity. And I know you're working more on the other side, which is a functional safety. And we hope that next year we will have something to say about that. But this year we don't. So we are not inventing anything. We just use what is available, and we try to make it in such a way that you fundamentally use it without realizing you're using it. So it's not that painful. I hope it answers the question. It's not real likely what you want to hear, but that's where we are today, and that's what we have to offer today. Yes?
Do you have any team of pen testing or something to prove that the security model is really secure?
It's a very valid question. That's not done yet, and we hope we will do it. So people getting in and actually trying to shake our system. We are not at that level yet where people have started to use it and shake it. It's a very beginning. To be honest, we presented at CES 3 weeks ago, and that was the first time that we were presenting applications which were running completely outside of the core OS and installed outside. So it's a bit green. We are working on it. But yes, you are very welcome to look at that, and we want to improve it. AGL, we have, if you put all the people working on AGL, it's about 50 people, depending who is counting. It's a lot and it's a little at the same time. But yes, it's something we definitely will do, and we know that the people who are going to use the system, at least in the car industry, are going to do it.
I would like to have, if there are people in the room that are willing to hack the system, we are ready to provide you all the documentation to be successful in hacking the system. We are very interested.
Yeah.
Why did you choose SMAC instead of Linux?
The question is, why did we select SMAC instead of SE Linux? There is a very simple reason. The first one, when we were working on Tizen project, we evaluated the hit in performance between SE Linux and SMAC. And one was about 15% of hardware, and the other one was 3%. So, that was already a big difference. Secondly, when Samsung did Tizen 2, they went using SMAC in a very, very extensive level because they didn't have Sinera at the time. And they ended by having a system with 22,000 rules. And so they did a huge investment to put down that system with this 22,000 rule to still use less than 5% CPU on a mobile phone. So it was really, sharply attuned to embedded. That was the first side. The second side was the complexity. When we looked at the default policy from SE Linux, at top of my head is 22,000 lines. Or 30,000 lines. It's huge. Okay? It might be even more than that, Jose. Do you remember the number? We looked at it some time ago. It's huge. Okay. And so when you look at it, there's no way to know how it works. Now, the people who wrote it are very smart. They are probably working for the NSA, and they have done it mostly for originally Red Hat. And in that case, we assume that it works. Okay, they may have kept a little bit back doors hidden here and there, but at least for most of people, it's just very acceptable. But we are incapable to say, if it does work or not for us, and we are incapable to actually manage it. So with Mac, we have a very small system. Actually, the entire mechanism is described on our documentation, and it fits on, I believe, 3 pages. Because we use it for very small things, and then we use Sinera. So that's the 2 reasons: performance and capability to master and to know what we're doing. Last question? Yes?
If I understand correctly, the applications go to the services through WebSockets?
Yes.
Can you have a word about how the service knows which application to propagate? How does it allow some functionality or deny it?
Today the system is static, today code, and we're actually working on specification to allow to get a discovery. That like a very equivalent to what you have in dbus, for example. But today it's static. And once again, it's because we do provide managed devices. That's not really a big problem for us. But we know that that will have to improve. Okay? And that's why we want you to help us. Okay? It's a good idea. You should do it. Okay? No more question? Great. Thanks.